Hi, everybody. My name's Mel. I'm from Lake Mac Council. Thank you all for joining our All Electric Homes webinar. This is the third one so far in our series of Renew webinars. So Council has done two already and they'll all be online. So if you've missed the first two, that's okay. You can always catch up on them. Now, before we begin, I'd like to acknowledge the Awabakal people, the land that I'm on today, and acknowledge the elders past, present, and emerging. Very lucky to be on Awabakal land. I think a lot of everyone joining tonight's probably also on Awabakal land. So we can all, I'm sure we all appreciate how beautiful our lake is and our beautiful environment. So I would like to introduce Dean Lombard. So Dean is a former social worker and he's an energy specialist who's worked on issues such as energy efficiency, fuel choice, consumer protections, hardship assistance, and community energy projects. He's interested in helping people and communities take control of their energy needs and make the system work for them. So welcome, Dean, and thank you very much for being our expert tonight.
Thanks, Mel. It's good to be here. Thanks everyone for coming. And yeah, I'm coming to you from the land of the Bunurong and Wurundjeri people of the Kulin Nation down in Western Melbourne in Victoria. Lots of different country all around the big island that we live on, from lots of different people. So yeah, look, really, thanks for coming. I'll dive into the presentation. We're talking about all electric homes. And yeah, as Mel said, if you've got any questions for me, put them in the Q&A. And at the end of my presentation, Mel will ask me the questions that are in the Q&A and I'll answer them as best I can. So the chat function is to talk among yourselves or to ask questions of each other while you're in the group. So I will get my slides up on the screen. There we go. And spoiler alert, yes, there are solar panels on the roof of the house in that photo, as there were in the introduction slide. While solar panels go great with an all-electric home, you don't need them to get a benefit from an all-electric home either. There are plenty of benefits even without solar. So that's often a question that we get. So I thought I'd throw that up there right now, given that that photo has solar panels on it. What I'm going to cover in this talk is, and it's going to be about half an hour, 40 minutes to make sure we leave good time for questions at the end. A bit of background, you know, the history of all electric homes, why all electric homes, and then onto the two issues that I think people most often ask, and that is what's the cost implication and what's the emissions implication of an all electric home versus a dual or sort of multi-fuel home. Then we'll talk about the main difference in appliances that you would have between an all-electric home and a multi-fuel home. And then some practical stuff about, well, okay, if I decide this is the path I want to go down, how do I do it and what do I need to know in doing so? So a lot of information. So I'll try to go through it clearly and simply, and please do ask questions if something's unclear or if you want to know more about something, because there's always a case that I don't always say everything that people need to know to understand what I'm talking about. So, and I forget things sometimes or I'm over or don't explain something clearly. So it's always good to ask a question if you're not sure. And that's what the Q&A is for. So I think an important bit of context is that all electric homes are not a new idea. They're an old idea that's been and gone and is now coming back again. Because before sort of statewide electricity provision, was so ubiquitous, which really started in the 1950s. People use lots of solid fuels in their homes, or solid or liquid fuels like kerosene, coal, briquettes, firewood, heating oil, and certain types of gases, in particular coal gas, which was often called town gas. That was sort of local area provision. So there was lots of, what we call thermal fuels, where you burn something to get the energy from it. And electric appliances were seen as a cleaner, more modern way forward because they weren't dirty. They didn't leave smoke or dust. And anyone who's lived with coal briquettes knows how messy that is. And even firewood, and even, modern firewood, say wood heaters, dealing with the wood is always a bit messy. So there was a real thing about it's clean. It's also cheap because this was in the era of, government ownership and provision of electricity using, massive coal mines. That was really cheap. So it was a real sort of change that happened in like the 1950s and earlier in some places and later in some other places, that brought all electric homes to the front. And this little picture here is, I put this here because I think it's sort of cute. This is the State Electricity Commission of Victoria, who used to put these badges on modern all electric homes to go, wow, this is a new all electric home. I spoke to a guy once in Latrobe Valley who had this really old ex sort of, energy company home that was sort of falling down, had holes in the walls, and he said, "Yeah, I've got one of these badges. I stick it over the hole in the wall to stop the draft coming in." So yeah, in the like 1960s, really, is when what became known as natural gas really started to happen, and it was really it's basically a byproduct of oil drilling, and that's why gas is so much more common in Victoria than in other states because there was so much oil drilling in Bass Strait in Victoria. But there's oil drilling in other places as well, and there was um, and methane gas was just a byproduct of drilling for oil. And the idea was, oh, we could actually sell this gas instead of just like venting it to the atmosphere or burning it. We could put it in pipes, send it to cities, and use it as a household fuel. And it was even cheaper than electricity because it was basically a free fuel that they got it for free when they drilled for oil. And that's really how natural gas sort of happened. And it really happened in larger cities and urban areas because that's where it was most cost effective to pipe it to and to distribute it. Um, and look, in colder areas, it became more common because it was much more effective and efficient than the electric heating technologies of the time. So it was used especially for heating. And you see that in all the large towns and cities in Victoria and in larger cities in New South Wales and especially in colder areas like Canberra's got a lot of gas heating too. And yeah, it's just methane, which is actually a terrible greenhouse gas. It's worse than CO2, carbon dioxide, but it was called natural gas to make it sound a bit sort of nicer than methane. And one of the impacts of the success of gas and the popularity of gas, I think, was that even in areas where it was not practical or cost effective to pipe gas, uh, bottled gas became common. And that was, in regional areas in particular, because people liked gas appliances so much. And it's because the gas was cheaper and, the technology for the electric appliances was pretty rudimentary. We all remember, resistive or ceramic electric hot plates that take ages to heat up and then ages to sort of just to heat, and gas was so much more responsive, so people really really valued it because of that. And of course, especially heating, gas heating burns a huge lot of gas. I've got ducted gas heating in my house. I just got my quarterly gas bill that was $600 because of a lot of gas. And when gas was cheap, it didn't matter so much, but it's gotten a lot more expensive, which has made a big difference. And yeah, this is part of what's changing now. The oil wells are mostly drying up. The Bass Strait gas field in particular is expected to be completely exhausted in a few years. Most gas production now is from coal seam gas or fracking, which is where they extract it out of the ground. It's a much more involved process. It's a dirtier process. It pollutes a lot more. And it's more expensive. Um, and and also a new gas export industry has been developed in Australia over the last sort of 7 or 8 years. So we now sell a heap of gas to other countries, mainly sort of Southeast Asia. I think Japan and China are big, and Korea are big customers for our gas. And that has exposed our gas production to global prices, which are much higher than what they were selling at local prices before they had access to the international markets. And these two factors have rapidly increased the price of gas. It's heaps more expensive than it has been for most of the time we've had gas. And that's really, that's one of the things behind our increase in electricity prices, because gas is used to generate electricity as well. And it's why people, like my gas bill and some of your gas bills maybe are much higher than we're used to. And and that's just the economic side of it. Gas is also, although it's often been talked about as being a clean fuel, it's not as clean as it used to be, which we'll sort of get to in a bit more detail down the track a bit. Now, so that's really the background of all electric homes back then and in the future, and the little bit in the middle of gas. Um, the last thing I like to do as an introduction is just to look at how do people use energy in their homes, and that's because it really guides what we talk about in terms of changing your appliances. And this chart, this is a New South Wales specific chart. It's like an average New South Wales for the average sort of home. So there's lots of variation, especially if you've got things like pools and that, which change your energy usage a lot. But this is sort of an average for a typical home in New South Wales. And it is a few years old. So the amount for lighting, I think, will be less now, because this dates from when compact fluorescent lights were the most common. But now LED lights increasingly are used, and they use a lot less electricity. But that's a bit beside the point. You can see in this chart that, hot water, heating and cooling are by far the biggest users of, and refrigeration are basically the biggest users of energy in the home. And that we really, in terms of electrification of homes, we really talk about hot water and heating, because they're the main two appliances that you can use either gas or electricity for. The third one is cooking, obviously, but cooking uses such a small amount of energy compared to everything else that it's less significant in terms of an energy usage perspective. Um, yeah, so that's, and all this other stuff, is only electricity that we use most. I think some people have gas clothes dryers, but they're not really that common. So yeah, so that's why we talk about heating and hot water mostly when we talk about electrifying. That's the main difference. And we also talk about cooking, because yeah, they're the three main appliances. So the first thing that people always ask is about the cost. And especially because those of us who grew up in areas where gas was common as a household fuel always believed, oh, it's cheaper. And it did absolutely used to be cheaper than electric, especially for heating, and for hot water. And that's really because of older electrical technology that was not that efficient, combined with very, very cheap prices for gas. And like the old resistive hot water systems and the old resistive cooktops and like resistive heaters were like a radiator sort of thing. They're a little bit more efficient than gas heaters in terms of energy in converted to heat energy out. But because gas was so much cheaper, that made gas a lot cheaper. Now, Renew has done a lot of research into what we call household fuel choice. Do you use gas or electric for your main appliances? We did two exhaustive modeling studies, one in about 2015 and one in maybe 2013, 2014, I think 2014 actually. Yeah, 2014, it's right there on the slide. And one in 2018. And they looked at, here's a house, one of its major appliances needs to be replaced. Should they replace it with gas or an equivalent electric appliance, a heater, a hot water system, or a cooktop? And they look at what's the upfront cost, what's the running cost, what's the maintenance cost over the life of the appliance, what ends up being cheaper. And the 2014 study absolutely found, yeah, the upfront cost was a bit more for all the electric options, but the running cost overcame that within sort of, depending on the appliance, between sort of 2 and 5 years. So over the lifetime of appliance, lower cost overall by the efficient electric option. The 2018 report found even more so, less upfront cost difference, greater running cost benefit because of higher efficiency. If you did it again now, I mean, this is 6 years old now, this study. If you did it again now, you'd find even more so, because the upfront cost difference is even smaller and the efficiency is even higher. The other part of the cost benefit is that even just having a gas connection, you pay that, you get your gas bill and your electricity bill, and they both have like the service charge or the daily charge. That's a fixed cost that you pay in addition to the volumetric, the amount that you pay for usage. That's sort of typically around $1-ish a day. Look, it goes up and down a bit, but if it's between 70 cents and $1 a day, just having the connection to gas is an extra 350 bucks a year, even before you've used any gas. And this actually led to a very significant finding of this study, which was if you only have one gas appliance, even if it's just the stove, you're always better off replacing it because you can then end the gas connection, and as well as getting the cheaper running costs from the official electric appliance, you also save that sort of $350 a year in having the gas connection. That was a really significant one. And yeah, and look, we looked mainly at reticulated gas, as in gas that's piped into your home, natural gas. But we did also in the first report, we also looked at LPG, bottled gas, and found that that was by far more expensive than either piped natural gas or electric. So we didn't even bother doing that for the 2018 report because it was already so clear that LPG was always more expensive than electrical appliances. Now, if you look into the costs, that's hard to understand a bit because gas is cheaper than electricity. And this is a point that the gas industry likes to make in arguments about electrification. So I just want to explain why gas being cheaper than electricity still doesn't mean that gas is cheaper than electricity to use. And I'll explain what I mean. I think I explained that really terribly, but I'll explain what I mean. The first thing is, and these are current typical prices in New South Wales, electricity about 31 cents per unit of electricity. It's measured in kilowatt hours. Gas is about 4 cents per unit, which is measured in megajoules. So 4 cents is much lower than 31 cents. But megajoules are not the same as kilowatt hours. They're different units. It's like comparing, centimeters to inches, and they are both metric. But basically, there's 3.6 megajoules in a kilowatt hour. So you have to correct it. You have to put them in the same units to get a proper comparison of the cost. And if you do that, gas is still, I forgot to change that. Gas is still cheaper than electricity. It's still about half the cost of electricity, 14.4 cents compared to 31. That should be. This chart shows 31. See. So yeah, gas is still cheaper than electricity per unit. So how could it be that it's cheaper to use all electric? Well, I'll tell you why. It's because the appliances are different. They have different levels of efficiency. Um, Gas heaters, 80% efficient on a good day. If you've got an older heater, it's less. If you've got a ducted heater, probably can be quite a bit less because over time the ducts wear out. And I think there's probably not that much ducted heating up where you guys live, but further down south, like there's a lot in Canberra, for example. Hot water, similarly, like instant hot water system, about 90% efficient for gas. But the equivalent electric appliances that use heat pump technology are many times more efficient than those gas appliances. Like an electric heat pump heater, which is a reverse cycle air conditioner on a heat setting, is like a bad one is 450% efficient. It can be up to 600% efficient. It puts out 6 times more heat energy than electrical energy that goes into it. And if that sounds like it breaks the sort of laws of thermodynamics, it doesn't, and I'll explain why in a minute. So when you, and yeah, similar to hot water, similar efficiency for heat pump hot water systems, even though gas instant hot water systems are very efficient compared to nearly every other type of hot water system, the electric heat pump is still far more efficient. So when you look at cost per heat out of the appliance rather than per energy into the appliance, that's when it works out that electricity is much cheaper. You see, even though gas is 14 cents a kilowatt hour and electricity is 30 cents, at 80% efficient, it's like 18 cents energy out, 18 cents worth of 18 cents cost to get the energy output. Whereas for reverse cycle air conditioner, even at 450% efficient, which is one of the less efficient ones, it's only costing you 6 cents to get that heat output because you're putting in far less than a kilowatt hour to get that result. That's really the heart of it. And this is why gas used to be really cheap, because the electric appliances just weren't as efficient. And since the 1970s and 80s, the technology has improved out of sight. And now the electric ones are so much more efficient that they just blow the gas ones out of the water in terms of fuel costs per heat energy out. And heat energy out is what we care about when we're looking at a heater or a stove or a hot water system. We don't want the electricity just for the sake of it, or the gas. We want the heat that it gives us. For emissions, people will say quite rightly, and the gas industry also likes to talk about this, gas has lower emissions than electricity. We make electricity with coal power stations and, gas, they don't really talk much about gas apart from it's got lower emissions. And look, it is probably true. I mean, it's sort of misleading to think about electricity emissions about the coal power stations, because as you know, there's lots of different types of power stations that make up the system, including solar and wind and hydro. So the correct way to understand the emissions of the fuel is to look at what's called the emissions intensity factor of the grid. So the emissions intensity factor of the New South Wales grid looks at how much of the energy demand is taken by all the different types of power stations, and looks at the emissions of all those different types of power stations in that proportion. You can see that New South Wales is less emissions than Victoria, which is the worst in Australia. Tasmania is the best because of all the hydro. South Australia is the second best because of lots of solar and wind and no coal. But you can still see that the electric grid has much more emissions than the gas grid. And look, many people will tell you that the gas industry underreports the emissions, and there's a lot of evidence that this is true. It's not as highly regulated. The emissions in the electricity sector are very highly regulated, and gas sector much less so. And also the gas emissions are getting dirty because of the increase in sort of fracking and coal seam. But it's still true that despite that, there are less emissions in the gas system than in the electricity system by a considerable factor. It's like 3.4 times. This is using, the conservative estimate of the gas industry, give them the benefit of the doubt. But you see, the thing that makes the cost work in favor of electricity also works for the emissions, because efficient electric appliances, they use far less energy to get the same value, to get the same output, because they're much more efficient. So, a gas heater on a good day is 80% efficient. Reverse cycle aircon, the cheap, not so efficient one, is 450% efficient. That's 5.5 times more efficient than the gas heater. That is much more than the 3.4 times less, like more emissions that electricity generates. So when you factor in that you use far less electricity to get the same heat as you would for the gas, you end up with less emissions, because it's, you're not using this much, you're using this much. Same for the hot water. But that's only one part of it. The other part of it is, as I sort of mentioned, gas is getting dirtier because of this, what they call unconventional gas, fracking and coal seams. It also creates other pollutants like wastewater, you know, and as I mentioned, prices. So gas is actually getting dirtier and more expensive, as we mentioned. So the future grid will have dirtier gas than the current grid does, and electricity is getting cleaner. Like already, and people don't realize this, like the New South Wales currently more than 30% renewable energy in the New South Wales electricity grid. I checked the figures yesterday. In the last 12 months, 31.6% of all the electricity used in New South Wales was renewable. And it's changing fast. Over the last 5 years, the share of wind and solar has more than tripled, and then it's going to more than double again by 2030. And these figures are from the most recent, what is it? The most recent greenhouse emissions projections. It's currently, like I said, 31.6%. By 2025, the expectation is it'll be 44% renewable. in the New South Wales grid, and that's based on projects that are currently underway as well as future ones. By 2030, 82%. By 2035, it's fully expected New South Wales will be 95% renewable. That change will make a huge impact on the expected emissions of the New South Wales grid. And yeah, the greenhouse emissions projections for 2030, which was published in 2022, estimate that by 2030, New South Wales will only emit about 15% as many emissions as they did last year. That's 1/7 the amount of emissions. That's a huge change. And it's similar for other states. And so if you go back to this chart, this is now 2023. This is the latest data available, right? As we said, 3.5 times more emissions in New South Wales. But by 2030, the emissions of the electricity grid in New South Wales goes from here down to there, lower than the gas grid. And that's not even counting for the additional efficiency of electrical appliances for the heat pumps that make the actual emissions of running appliances even less. And so it's the same everywhere. Even, Victorian, Queensland, WA, the only places where electricity emissions will still be higher than gas, but they'll be much closer. South Australia and Tasmania got down to almost nothing. So it's a huge change. And when you're thinking about changing an appliance, you buy that appliance today. If you get a new heater or a new hot water system, you're buying it today. Its economic life is 10 or 15 years. You'll probably have it for 20 years. Over that period of time, like within 5, 6, 7 years, the grid will be cleaner than the gas grid. So even though right now the electricity grid is more emissions intensive than the gas, early on in the life of the appliance, that will flip. And that, as I said, is not even considering the effect of the extra efficiency of the appliance. So I think it's really useful to understand that we should always look at appliances over their life and not just snapshot where they are now. And look, as part of that fuel choice research Renew did a few years ago, we also looked at the emissions impact right across Australia, and pretty much everywhere except one or two places where there's virtually no heating. Apart from those one or two, everywhere else was the all-electric home was lower emission than the dual fuel home all around Australia. So let's look at the appliances. And there's this evolution of appliances where we talked about the glory days of the all-electric home back in the 1950s and 60s. These old clunkers were like the groovy, newfangled appliances of the day. They replaced wood stoves and wood heaters, kerosene heaters, etc. By the 90s, we're talking about gas. And again, in many places, it depends on where you live, whether it's LPG, whether you've got reticulated pipe gas. But it's fairly common for one or more of some sort of gas heating. I mean, this picture is really probably more Victorian. One, you're probably more likely to, where you are, to have like small portable gas heaters, if at all, I'm guessing. Gas hot water systems, gas cooktops, and by now, 2020, should say 2024, induction stoves, which is a very different technology to these resistive or ceramic stoves. They're light gas in that you can turn them up and down and they respond instantly. Heat pump, like your reverse cycle air conditioner, also with hot water. That's a heat pump. That's a little magic thing that creates more heat than the energy that goes into it to run it. So these are the appliances of the all-electric home, and I'm going to go into them in a bit of detail. But look, first I'm going to just give a little, hopefully not too techie, dive into how the heat pump works, and that's only because people often find it hard to believe that heat pumps put out more heat energy than the electrical energy that runs them, because many of us are familiar with, the law of conservation of energy and that. And the trick really is that the electrical energy that runs the heat pump is not turned into heat. So you're not using the same energy. A heat pump is like a fridge in reverse. And in fact, when you're running your air conditioner as an air conditioner, as a cooler, it's just like running a fridge. It's just blowing cold air at you instead of making your food cold. But when you're using it as a heater in a heating mode, or in a hot water system, it's like a fridge in reverse. The electricity that powers the appliance is used to run a pump and a fan. The fan sucks in air. The pump pumps refrigerant around sort of a system of pipes and it concentrates it. And basically, the refrigerant, the compression of the refrigerant sucks heat out of the air into the refrigerant, and then it expands somewhere else to produce the heat that comes out. So the heat pump is moving heat from one place to another. It's not creating heat out of nothing. That's why the electricity that runs it is not the heat that comes out of it. And that's why you can get more heat out of it than electricity that goes into it. And people sometimes ask, how can it get heat out of the air when the air is cold? And certainly some people say, do they work when it's cold outside? The answer is yes. And the reason why is that cold air still has heat in it. And I know it doesn't feel like it when you go outside and it's like 4 degrees, but we're talking about the more technical definition of heat. And cold air still has heat in it. And the way to explain that is if it's 4 degrees, it's cold, you feel very cold. But if it's 0 degrees, it's a lot colder, right? You notice a difference. It's a hell of a lot colder. That means there must be some heat in the air to make 4 degrees less cold than 0 degrees. We don't feel it as warmth, but it's still got heat. And at -20, at -40, there's still heat in the air. There's heat in the air at any temperature above -273 degrees Celsius. That's the level at which there's no heat. So even though you can't feel the heat, there's heat in the air. And a heat pump probably wouldn't work. It definitely wouldn't work at -273 degrees. It probably wouldn't work at -100. But they're all over the place in Scandinavia. And they have temperatures well below zero, and their heat pumps work fine. Some of the cheaper, sort of crappier heat pumps might not work as well in really cold weather. And one of the specs on the sheets, if you buy one, is talks about its efficiency in different ambient temperatures. So it's still a consideration, but there's always heat in the air, and the heat pump takes the heat out and puts it in the house or in the water cylinder. That's how it works. And that's what enables it to be so efficient, is that the electricity is not actually producing the heat. That's different to like those old-fashioned stoves where they zoom the electricity around the coil and heat it up by sort of friction. That's also how those radiant heaters work. It's resistance in electricity flow. It turns electricity energy into heat energy. That's completely different with these heat pump technology. So look, I'm going on a bit, so I better speed up a bit. So the appliances, they are different, and people often ask about, oh, is it going to be okay? I'm not sure about changing. Heat pump hot waters, I'm going to start with them because they're probably the least common and the ones that people know least about. So a heat pump hot water system is a storage hot water system. Storage in the sense that there's a tank, it's filled with water, and then heat is applied to the water to make it hot water. Same as your old-fashioned in the ceiling, sort of heat up overnight electric hot water systems. Same as your big sort of cylinder electric hot water systems or gas storage hot water systems. Different to the modern gas instantaneous hot water systems that heat the water as you use it. So that's the main difference that you might experience if you're used to a instantaneous. But the instantaneous technology is relatively recently that it's become very common. Well, when I say relatively recently, probably last 10 or 20 years. Before then, storage was pretty much the most common. And the thing with storage hot water systems is like anytime, whether it's electric or gas or a heat pump, they work well when the tank is the right size for the users, and when it's properly insulated. So people often ask, oh, will a heat pump hot water system provide as much hot water as I need? And it's like, well, as long as you buy the right size, it will have enough. I mean, they basically, they size them according to the number of bedrooms in the house because that's a good sort of proxy for how many people will typically use it. That's usually the recommended approach. So that's the main thing that you got to look at when you get it. If you're getting a heat pump hot water system, make sure it's the right size for your house. And like anything, don't get the absolute cheapest ones if you can possibly avoid it, because they're just, the absolute cheapest. If anything, is usually not quite as good. And in the super cheap heat pump hot water system, we find bit noisier, maybe a bit less reliable, higher rate of failure, typical with really cheap of any product. The mid-price ones perform great. When we did our analysis, we I think the first analysis we looked at like the market, the highest quality system on the market, but for the second one we decided we should pick a more in the middle of the range one, because who's going to buy the really expensive top one? And it performed as well, even though it was less efficient, a bit less efficient, still efficient, but a bit less efficient than the sort of most efficient one, most expensive one on the market. The lower purchase cost made up for the small decline in efficiency. And the other thing that we found with the one we did was it actually performed better in colder temperatures than the most efficient, super expensive one on the market. So, like with anything, every different model of appliance is a bit different and, performs differently in different ways. So it's always good to find someone who knows about them, or to do a bit of research, understand what the specs mean, read the spec sheet. It has, they all come with a spec sheet that says how efficient they are, what sort of refrigerant they use, what sort of noise. We do recommend low noise is good because, it's on the side of your house. It might heat up when you want quiet. And if you're in an area, in a built-up area where there are neighbours nearby, some councils might have limitations on how loud an equipment like a heat pump might be. Low noise is sort of 40 to 50 decibels. Up to about 60 is pretty good. Like, 60 is about as loud as a fridge. So yeah, look for low noise, but it'll be the more expensive the low noise it will be, but the mid-price ones perform pretty well. Look for a high coefficient of performance. This is the rating of the efficiency. Like if it's 4.5, that means it's 450% efficient. The coefficient of performance means this is how much you get out for each unit of electricity that you put in. So again, the higher the COP, the more efficient it is. But you've got to discount it off against, how much extra it costs. Like I say, the middle of the range one's usually good. Probably more important is find an installer who knows heat pump hot water systems, because a lot of plumbers and traditional sort of hot water installers know much more about the older type of electrical ones and the gas ones, and know less about heat pumps. Some of them, believe that they don't work properly when it's cold. And they might not have a supplier who can supply them. One of the tricks with hot water, if your hot water system fails, there's always an urgency to replace it. So that might limit your options, especially if now when heat pumps are still not super common. So I would recommend, if your hot water system is really old and it's going to fail in the near future, you expect, then I would do some research first to find out, what are the heat pumps available? What's the model that I want to get? If I do get it, who would I get it from? Do they have them in stock? Be prepared. I've known a few people who were dead keen to get a heat pump hot water system, and then when it came to the crunch, the plumber turned up and said, "Sorry, I can give you a new gas one today, but it's going to take 2 weeks to get the heat pump one in." They didn't want to go 2 weeks without hot water. That was it. So be prepared. And look, some people just go, my hot water system is 25 years old. It's going to fail. I might just change it now instead of wait for it to fail and put up with the inconvenience of the sudden cold shower, unexpected. So that's another thing to think about. Yeah, some people might find that they need to put in an extra circuit for a heat pump hot water system, similar for a reverse cycle ignition. It depends a lot on your house. So again, it's good to do a bit of research to find out what the implications would be for your house. Some people ask about instantaneous electric hot water systems that heat up the water as you use it. They are available, but they don't use heat pumps because heat pumps don't work instantaneously like that. They're resistive. People who have them like them. They need that super high capacity circuit. They're not very common. They're very expensive. They're probably probably more expensive to run because they're using resistive electricity, but you do have some savings by not storing it. So we haven't really done the analysis of those, but they're very expensive to buy, which sort of puts them out of the picture for this sort of analysis that we do. The other thing with hot water, especially if you've got solar, but also if, as is happening more and more in the electricity system, cheaper prices in the middle of the day. If you got any sort of storage hot water system, you can usually program to heat up during the middle of the day instead of, say, overnight or whenever. And that way you can take advantage of your own solar if you've got it, heat your water for free, or cheap electricity in the middle of the day, which more and more increases becoming an option for energy retail. I just noticed that this one looks like a person. Look, there's its eyes and a nose and a mouth. I never noticed that before. That's cute. Um, eh, Reverse cycle aircon. So you're probably more familiar with this because a lot of people have these for cooling. They work great for heating. It's the most efficient, cost-effective form of heating that is available for residential. Obviously, unless you have a wood heater and you've got free wood. Um, when we have them as air cons, they're often just in sort of one main room in a hotter area, maybe in a couple. Um, for heating, it depends how much heating you need. In really colder areas, you might want a few around. I know that when we did ours, we sort of sized them to size the house, maybe a large one in the living area, one or two smaller ones in other parts of the house. Really depends on how much heating you do, how well insulated your house is. Um, the insulation is really important when you're looking at heating. I mean, it's important for all forms of heating. If your house is well insulated, then the heat that you put into it with a heater will stay in the house for longer than if the house is poorly insulated. But if it's particularly, I find with reverse cycle air cons, especially if there's one or two around the house, if you're trying to heat up the whole house in really cold weather, that's really the only way you can do it, is to have it well insulated, because if you've got one heater or a couple, the temperature in the house sort of equalizes over a period of time in the house if there's a bit of air movement from the fans. But it needs to be insulated for that, otherwise you lose it out the ceiling or sort of out windows if you don't have window coverings. So good to keep that in mind. If you can get ducted heating, I'm guessing that ducted heating is not as common up in Lake Macquarie as it is in Canberra and Melbourne. They're less efficient anyway, so don't bother. Get insulation instead, and the heat stays in the house. Um, some people don't like the fan, the feeling of the fan that's blowing the air out. Um, and that's fair enough. Feeling moving air on your skin makes you feel a bit cooler. So, but if low fan speed is great for these, because the idea is to mix the air around the room, not to blow it directly on the people. So yeah, use a low fan speed. Um, like any appliances, look at the star ratings. That these have star ratings, air conditioners, that show how efficient they are. It often costs a bit more to get a more efficient one, but it's usually worth it in terms of the energy saving. And when it's got the star rating, which aircons have, it's easy to work it out if it's worth it, because it'll have written on the star rating sticker a number of kilowatt hours, which is how much it uses in a typical year. If you've got a 7-star one, say, and a 5-star one, and 7-star ones, I don't know, $200 more expensive or something. You can look at, this is how much that one uses, whatever, 400 and something. This is how much the 5-star one uses. It's more. You can multiply it by your electricity price and see what's the difference. How much less will it cost me to run the 7-star one than the 5-star one, based on the annual usage that's written on the sticker times by my electricity price. That's how much I'll save each year if I buy the more expensive one. How long will it take to offset the extra cost of buying the more efficient one? That's what I did about 10 years ago when I bought a fridge. I was looking at, I don't know, a 4 and a 6-star fridge. 6-star fridge cost a few $100 more. I did that quick math, and it's like, it'll pay for itself in 2 years. In 2 years, that less electricity, the more expensive one will use, because it's more efficient, will match the extra price I paid for it. It's a no-brainer. So that's what's a useful thing of those star rating stickers. Like the heat pumps, find an installer who knows what they're doing, because I've seen dodgy installations of any appliance, really, hot water systems, air cons, gas and electricity. Find a good installer, ask people who've had stuff done, if they can recommend anybody. And again, like with the heat pumps, look for low noise. Yeah, that's always helpful. It might cost a bit more, depends on where you live and where it's positioned in your house. If it's out the back away from the bedrooms and that, might not bother so much. There's also different types, as well as the one on the wall, which some people find really ugly. I tend to not really notice them. But you can conceal them in sort of paneling like these people have done. You can get wall-mounted ones that put the heat out closer to the ground, which people might like in colder areas. You can also get what they call multi-splits, where it's got one big compressor and a number of indoor units, each with its own control. They might be, people think, oh, that sounds like it makes a lot more sense. They're actually a bit less efficient because of the way the one unit's sort of trying to drive all the different ones, but they might be the right solution if you've got limited space to put, if you need a few units, but you've got limited outdoor space for the outdoor units. So that's a benefit of those ones. The induction cooking, a lot of people haven't really used it. A lot of people love cooking with gas, and I got to say, I'm one of those people, and I've got gas in my house, so I still cook with gas and heat with gas and hot water with gas. I've got no choice, I rent, so that's a thing that faces a lot of people. Um, Induction is a relatively new technology that heats in a completely different way to the older electric ones and to gas. It uses induction, electrical induction, to basically heat up the cooking appliance itself, the pot or the pan, directly rather than by applying heat to the outside of it. It basically excites like the electrons or whatever inside the material that the pot's made of to make it hot. That's why it's got super fast control, like a bit like a gas one. You turn it down, it goes down straight away. You turn it up, it gets hotter straight away. So that is that and many chefs are moving to induction because they're safer, they're quicker at heating up than a lot of gas. And yeah, no pollutants, like, gas puts pollutants inside the house. The flip side is it only works with ferrous cookware, stuff that's got iron in it. So it doesn't work with aluminium, it doesn't work with most copper. It usually works with stainless steel, apart from the really super cheap stuff that's mixed with lots of other stuff and doesn't have enough ferrous material in it, and it works fine with cast iron. And the way that you test it is you stick a fridge magnet on it. If the magnet sticks to the pot, it'll work with an induction cooktop. You might be able to borrow one from the library. I think Mel might chat at the end about the coming sort of kits at the libraries, where energy efficiency kits that can have a few stuff to test electrical efficiency in your house. I'm not sure if induction cooktops part of them, but what a lot of people do is, borrow or buy a portable induction cooktop. You can buy them from IKEA for like $50 or something. You can borrow them from some libraries and that. They plug into a power point. You can test out, see what it's like to cook with them. Renew used to have an induction cooktop. It would lend to people who were a bit skeptical about changing to induction. I had a go, blew my mind. It was so great to cook on induction. If I buy a house, I'll absolutely get an induction cooktop because it works so well. Quickly, safely, quietly. If you're in the market for one, like everything, there's some cheap, slightly crappy ones, and there's some super expensive ones, and there's a lot in the middle, and they're generally pretty good. They all have different sort of control schemes, and I'd really recommend that you try them out because different people's minds work different ways. And, I know I was at a friend's house using one, and I'm like, I don't understand how these buttons work. And they were like, no, it makes perfect sense, blah, blah, blah. And I didn't get it, they got it. So I really recommend you try that. And if you're buying one, try the different ones, find out the controls that make sense to you. When installing, more likely than, say, with hot heat pump, hot water, or aircon, it's quite possible that might need a new high capacity circuit from the switchboard, because the induction, although it's very efficient and doesn't use much electricity, it has spikes in demand at certain parts of the cycle that need a whole lot of electricity once, just for a short time. So it might need a higher rating than your house might have. So that will be worth checking out. And if you're shopping for one of these, if you look at the spec sheet, it'll say what the instantaneous demand needs to be. So you'll be able to figure out then, have I got that capacity circuit in my house, or have I got room in my switchboard to install one? So might be a bit of upfront cost, but it's really worth it because you're getting gas out of your house, you're saving that gas connection fee as well as the gas usage costs. You're getting pollutants out from inside your house, pollutants that have been recently linked to sort of childhood asthma and other respiratory illnesses. So that's really worth it. Let's move along to, okay, if I want to go all electric, what do I do? How do I do it? Um, well, let's go through a few aspects of that question. The first thing is is some financial assistance from the government to for some of these appliances. And this is part of the New South Wales Energy Savings Scheme that is all about improving energy efficiency and reducing energy usage, or what they often call increasing energy productivity, which means using less energy to get the same work done. Because sometimes when people think of energy efficiency, they think of using less, but the whole idea is that you use less, but you're not getting less. You use less to get the same or more done. That's what efficiency is about. So that's what this program supports, and um, it's sort of aimed at homeowners, not really, doesn't really work that well for renters, though you can get LED lighting, which renters can do with permission, but they do have rebates, which is like a discount that they pay back to you, or that they reduce from the upfront costs for hot water systems, for reverse cycle air conditioners, also pool pumps and LED lights for installing them in your house. The rebates, it's a bit complicated. There's no single easy dollar figure what you get from the rebate. It depends on what appliance you're installing, what appliance it's replacing, because the whole scheme is predicated on we're saving emissions and there's a value of emissions. So it depends. But when I looked at the website a little while ago, it was a bit hard to find the info of how much you get without making an application. But it looked like you can get up to about $1,200 for hot water, up to about $1,000 for aircon. That's a few months ago. I'm not sure if that's changed. And like I said, it does depend on the appliance, but it's significant amount of money that can make it a bit easy for you to get the upgrade. So definitely check out the New South Wales Energy Savings Scheme. I think Doug's put the link in the chat. Um, and it's a pretty good web page. You can, navigate around it and see lots of info about the various different programs. So that's about, easing the financial burden. And when you think about the finance, also do remember that, all this modeling has been done by Renew and others that show that it's actually cheaper to make this change in the long run. Even if the cost of doing it is a bit upfront, you save all this money by reduced running costs. So it is worth it financially. The rebate is especially helpful if you've got it, many of us, the initial upfront cost can be a bit of a stretch, even if the benefit is there for us. Making a change, people often ask, well, should I do all them all at once? Should I just rip out all my appliances and change them over? Or what should I do? Which one should I do first? And really, whatever you like, it really is the answer. But I would normally go, wait till your appliances wear out. You've already got your heater or your hot water system, it's working fine. If it fails, or if it's getting old enough that you sort of think it's going to fail, I should replace it. That's a good time to change, because you're going to have to be spending the money anyway. So why not spend it on the electric one instead of replacing it with the gas one? And, build in that saving for your future, because once you replace an appliance, it's there for 20 years longer. So that's a really good time to do it, with the caveat that if you've only got one gas appliance, it's always economically worth it to just rip it out and replace it with an efficient electric one, even if it doesn't need replacing. But, some of us are like, let's, use embodied emissions and production of the appliance to the fullest capacity. Let's keep it until it needs to replace. So that's, of course, that's also environmentally sensitive to do it that way. So it depends on what works for you. Some people just like to go, we're doing it, let's do them all. Some people go, we'll do them one at a time. But there's never a good time. Some people go, should I wait till the technology improves? And it's like, it always improves. You'll always be waiting for the next version. So do it when you're ready is probably good advice. And I mentioned a few of these things to check. Do you have power capacity for the appliance demands in your switchboard? If you need new circuits, do you have spare spaces in your switchboard to put new circuits in? That's a couple of good pointers to think about. And locations. Where would you put the appliance in the house? Often it's in the same sort of place where the existing one is, but where are the outdoor spaces for the external units for the heat pumps? And there's lots of options for them. You can hang them on a wall, you can put them on the ground, you can stick them on the roof, but think about where the locations for the compressors would be. And in some places, if you live in a more build-up area where there's like in a townhouse or something, you might have much more limited options. So that's when you've really got to think about, okay, how can we do this? And look, if you're not sure about the heating thing and you've got some other form of heating like a wood heater or a portable gas heater or something, and you've also got an air conditioner, just try it out. I recommend this to people, especially in people in colder areas who are really used to having gas heating. It's like, just try heating with your aircon for, on those cold autumn days where you just have the gas heater on for one day or something, and see, does it keep you warm? And what's it do to your bill? And, I've spoken to a few people who did this. They just used their existing aircon that wasn't even a modern one or even wasn't even super efficient and found they saved hundreds of dollars by using that instead of their gas heater. Because you get that, because that efficiency really drives the savings. So that's a good way to try it out if you're a bit not sure. If you're building a new home, um, we look at this too. Absolutely don't ever install gas appliances. Make them all electric. It's the cheapest way to do it because you're paying for everything up front. You're paying a gas connection fee. You're paying for brand new gas appliances if you're getting gas. May as well just not get that gas connection, get new electric appliances and design the house to work with the efficient electric appliances, and you'll be ahead from day one. And if you are doing a major reno, because I guess going back to when you do it, if you're doing a major reno, that's also a good time to do the change because you might be pulling out lots of stuff. And yeah, also if you're doing a major reno or buying a new home, really think about the energy efficiency, the thermal performance of your home. The current standard for new homes is 7 stars. It's sort of just come in. I think it's being implemented as we speak. Um, Going up to 8 or 8.5 stars, according to research that Renew did a few years ago, is very cost effective in terms of the extra that you spend to make the house more thermally efficient than the legal requirement will be worth it within 5 or so years, 5 to 7 years, in terms of reduced energy expenditure, energy usage. So it's very worth it to do that. If you've got an older home, it's very hard to get it even up to 7 stars, but it's not that hard to get it from up to 4 or 5 in many cases. And given that a lot of older homes, like built before 2000, often 2 or 3 stars, um, you can make a lot of gains, and the marginal benefit of getting a really poorly performing old home that's maybe 1 or 2 stars up to 4 or 5, that's a huge change, a massive reduction in your heating expenditure. This is actually a few years old now, 2022. It's locked up there now, by the Climate Council. They did some modelling of savings for the typical home in each state for going all electric compared to being dual fuel. And look, these are a bit different to the figures Renew came up with, but every modelling approach that does this uses a bit of a different approach, and they all come out a bit different, but they're all in the same ballpark. It basically is around $1,000-ish a year for that benefit. And in some, in Hobart, and Hobart's weird because there's not much gas in Hobart at all, really. But yeah, colder areas often a lot more. So there's definite benefit, and you get the benefit every year. As I said at the start, solar panels go great with an electric home, especially if you can heat up your water in the middle of the day. Solar has great environmental benefits in many ways. And it's really a no-brainer to be all electric when you have solar, because when you got solar, the most value is by using electricity that you generate. And the more non-electric appliances you have, if you've got gas or wood, you simply can't use your solar energy with those appliances, but you can if you've got electric appliances, so you get better benefit, especially nowadays as feed-in tariffs are much lower. Um, Close it if you have a gas account. If you've got a reticulated gas account, you need to speak to your retailer and your network provider. There might be a fee You might have to sort of push a bit because they hate people disconnecting. You don't have to have the meter removed. There's an extra fee that can be quite expensive, up to like $1,000 sometimes to get the meter removed. A lot of people will just leave them there. It's considered best practice to remove the meter and the pipe to the street for safety reasons. In Victoria, where there's like 80% of houses are on the gas network, the regulator recently capped the fee for removing a meter to $220. And I think that's likely to happen in other states eventually. This shift towards electrifying houses is happening faster and earlier in Victoria than anywhere else because of so much gas. So I think in the future there'll be some sort of cap on the gas removal abolishment fee everywhere, but that's not the case yet in New South Wales. But that's the sort of things you want to consider. If you've got bottled gas, it's a lot simpler because you can sort of close your account and they can remove the gas bottles. And I'm not quite sure on all the ins and outs of removing the infrastructure, but that would be good questions to ask. Yeah, look, I'll skip over this because we're running a bit over time, but you can go all electric by getting off petrol as well. After gas, petrol is the next biggest sort of, it's probably bigger than gas actually. That's the other big non-electric, like the other big fossil fuel that we use. So, different issues for electric vehicles in build-up areas versus regional areas where you might have much longer distances, but many people who live in regional areas have found that they go quite well, and most people find they mostly charge them at home. So definitely have a look at some of the links that Doug's put in the chat about electric vehicles. And keep in mind that although the EV rebate finish on 31 December they used to get a $3,000 discount for buying an EV. The government found that that was just pushing the price up by $3,000, so they ended it. You still have some fringe benefits, tax benefits, if you have a novated lease. I don't even understand what that is, but it's, if you know what it is, you know what it is. That's a benefit. But there's also a program in New South Wales to develop EV infrastructure all around the place. So, EVs are definitely the future. Sort of by the mid 2030s, they'll be the most common sort of car around by all accounts. So something to think about as well. I'm going to skip really quickly through these unless there's some questions. Some people with lots of solar might find a resistive hot water system works as well as a heat pump one because they've got so much extra solar. They can use lots of electricity to heat water and it's still free. That's a consideration. Maybe if you've got a rural property and lots of roof space and solar. Solar thermal, that also works pretty well as well. Actually, in an area like where you guys live, that's more likely to be a pretty cost competitive with heat pumps, actually. So that's another consideration. The risk with these is if they don't generate, you end up having an electric booster, which can cost a lot because it's just resistive. But talk to people who've got solar thermal hot water systems if you're thinking about that as an option. Evaporative cooling, I don't know why that's here. Because but I guess they're common. Thing is, the more humid it is, the less well they work. So, and everything's becoming more humid. They don't use much electricity. They use a lot of water. Reverse cycle air conditioners is generally more cost effective when you consider all those costs. And they cool more effectively when it's hotter and when it's humid. So, and they can't provide heat, and you buy a reverse cycle air conditioner, it cools and it heats. That's a double, you get double value. There's a few special cases, very low hot water consumption, a heat pump might not be worth it. If you've got special cooking requirements, you might need gas for some things. People might sometimes use a barbecue or a camp cooker or rig up bottled gas just for cooking. If you're off grid, you might need to consider differently because you might need to limit how much you have to use from electricity. People often ask what happens if there's an outage in an electric home. Well, there's no electricity. Thing is, most modern gas appliances also use electricity, so they also can't be used without electricity. A cooker is often the exception, a stovetop, but like I said, if you've got a barbecue or a little camp cooker, that's a good option. And hot water, yeah, that's a pain. Like, gas, instantaneous hot water doesn't work without electricity. And if you've got a tank full of hot water, it's going to last a few days. Anyway, it takes a while before the water cools down. Outages are always inconvenient. If you're in an area that's prone to outages, even, then backup power options are worth considering. And even some things that work with, say, a smaller bottle of LPG could be useful for you if that's a thing that affects where you live. That's pretty much it, though. Two more things I'm going to do. One is this list of useful resources, which Doug is going to whack in the chat for us. I already mentioned the New South Wales Energy Savings Scheme with the rebates. They've got this good climate and energy action website with heaps of information about energy efficiency, other stuff. You can get home energy assessments. Look at homescorecard.gov.au. Sustainability Victoria has become, and I think it's because all electric homes is a big thing in Victoria at the moment. They've got great information at that link on everything you need to know about going all electric. The Getting Off Gas Toolkit by Renew is also a really good one. This is a fairly new thing that Renew's done, and it covers everything I talked about, but in much more detail. It has case studies of people who did it, how to plan it, how to choose the appliances, everything you need to know. So highly recommended. And I'm sorry I talked for so long. I hope that it was interesting, and we should throw to all your questions.
Thanks so much for that, Dean. That was great. I it always amazes me the difference between appliances and how much money you can save by making just a smarter decision.
Yeah, no, it really is quite remarkable. And it's just that thing of like, if you don't know, you don't know. And that's why, those resources, and like Doug's put them on in the chat, they're really good. Like the Getting Off Gas Toolkit, the Sustainable Victoria little sort of web sort of portal, such good information for stuff that people otherwise don't know about. Yeah.
Yeah, no, that's brilliant. And I will just very quickly before we get into the questions say to our Lake Mac residents, very soon in the libraries, you'll be able to loan a home energy audit toolkit so you can check how much power your appliances are consuming. It's got a really fancy infrared camera so you can check for drafts and different things as well in the house. So keep your eye out, that'll be up. And you can also get portable induction kits. So if you'd like to test the induction cooker out before you commit to buying one. I recommend giving those ones a loan. They're really great. And yeah,
Yeah.
yeah, they're brilliant.
Yeah,
So
no,
you
that
get,
is a great idea. Like, yeah, I've certainly found that use for myself to do it. Because as well as seeing if you like the induction cooking and convincing and discovering that it is a lot like cooking with gas, you can also see if your pots and that work on it.
all right. So I did see one question pop up in the chat. I'll just ask that one before I get to the Q&A ones. So someone wanted to know, are solar batteries worth it?
That's a good question, and it's really hard to answer because the answer is it depends. And it depends so much on how much electricity you use, how much solar you have, how much spare solar you have that you don't use during the day that you could use to charge your battery. As a rule of thumb, like the basic way to work it out is how much extra solar do I have that I don't use during the day? And you can look at your bill and see how much you export divided by the number of days and get a rough estimate of, because anything you don't use during the day, that's what you've got to put in the battery. And then you should go, how much electricity do I use overnight? That can be a bit trickier, but if you can use one of those power meters, maybe, or you can even just read your meter, you know, once your solar stops, read your meter. Once your solar starts the next morning, read your meter, work out in between, subtract the small number from the big number. How much electricity do I use overnight? Do that for several days, get an average. If you've got a smart meter with time of use, then you can probably look at energy data, get that. But that's what you do. How much spare solar do I have? How much do I need overnight? Is that enough? How much will that be useful? If I want to use as much as I can overnight, okay, what size battery would I need that will hold all that spare solar? How much of my nighttime usage will it get me? What will it save me? Because, and then go, okay, that's what it's going to save me every year. If you work it out on a yearly basis, how much does the battery cost? Okay, in 10 years' time, because that's the economic life of the battery is like 10 years, will it save me more money than it cost me to buy the battery? That's sort of the basic way to do it. There are lots of home battery calculators online. There's a website called Solar Quotes. and there's another one called solarchoice.com.au. They both have good battery calculators where you can type in your usage and your solar system size and it works it out. Doug's also noticed that there's a battery storage webinar next week that's got a lot of this information too. So that's basically what you do. But the other thing is, it's not just about saving the money. You might also want it because you have outages. You know, you might live in an area where there are lots of outages, or you might have really critical equipment that you use where you really don't want to have an outage. The battery might be worth it to keep your electricity going during an outage, even if it's not saving you money. So that's another consideration. But if you do that, you've got to make sure that it's set up and your system is set up so it works when there's an outage, because it doesn't necessarily do that unless you get the system designed to do it. So yeah, that's the consideration.
Thanks. And yeah, there is the webinar next week. So you can register for that on the council website under events as well. And we'll go over battery storage in that one. Another question, how significant are health impacts of gas? It's a hot topic, this one.
That is a good question. And look, I haven't got good stats in my head or in my notes, but there's been a few studies done recently. And probably the most significant one is the effects of burning gas inside the home because of all the byproducts of and it's carbon dioxide, carbon monoxide, and there's methane, and there's particulates as well from the flames and what they burn. So they do put stuff in the air of your home, and the health impact is more around respiratory issues. And it's more around if people are already a bit prone to respiratory issues, or if there are very young children whose systems are still developing. So, there was one or two studies that appeared to show a link between gas burning in the home, like for cooking or heating, and more likelihood of childhood asthma. But I think, probably more research needs to be done to be more conclusive, but there's certainly an indication that it's an issue. The other factor in it is, of course, ventilation. And if you say have a gas stove and you've got really good ventilation right above it, and it's a good efficient gas stove, it's probably less of a worry than if you've got older stuff and less ventilation. But even in the best circumstance, burning gas in the home does put particulate matter and that in the home, and that can aggravate or inflame respiratory issues. So yeah, the research on this is really still being done to the full extent that it needs to be, but certainly is a big concern. I mean, there's similar issues with older wood heaters. And I'm not sure if Doug put the links in the chat earlier about wood heaters, but some wood heaters don't basically are so sealed up and work so efficiently, they don't really have an impact inside the home, and others do because of, the way they're designed or the age of them. So that's also a consideration with any sort of burning of anything. And having the house well ventilated is very important when you've got any sort of burning fuel inside the home.
Another question we've got, it says, I have just installed solar on my roof and I'm loving it. If there is this big push to go all electric, why do all the electrical distribution authorities only allow to install 10 kilowatts per house, single phase, as I would have installed more solar if I was allowed to?
Yeah, that's a good question. And this is still a bit of a moving area because there's been a lot of solar installed in Australia in the last sort of 10 years, and the networks it's in many cases it's more than the existing networks can actually handle in terms of the exports. But it can also be more than is needed for actual usage. And if solar systems are pumping unused electricity into the system and there's not enough electricity being used, it can actually destabilize the system. And they've had this issue in South Australia in particular, which has the highest solar penetration in Australia and also low daytime energy use because of lack of industry. And they've had to shut down solar systems to stop them from exporting. So that's why the network's doing that. And they're actually, I'm involved with a few networks in working out ways to allow greater levels of solar panels on people's homes. So it's a complicated area that is actually about the energy system, the electricity system as a whole, and how it works together. The good news is that all the networks are working on ways to be able to accommodate more solar, because it's actually really useful in the network also to have a lot of solar at different times. So the limit is really about during that peak solar generation time, the middle of the day when it's sort of sunny and there's not heaps of demand, that's when there can be too much solar generation. That's why they have limits, and they're working on systems to like dynamically adjust it so that maybe you might limit solar exports in the middle of the day, but allow more solar exports earlier and later in the day. That would solve the problem. That would allow bigger solar installations, but it also involves working with communities to get people comfortable with the idea that they might have their exports limited in the middle of the day. And people don't like that idea, right? So it's a bit of a complicated community sort of problem about that. And, I'm pretty confident that, this will be worked out and we'll see larger solar installations on homes and businesses and much greater use of that rooftop solar in the network. But it will also involve probably some curtailment or, restricting exports in the middle of the day unless there's enough batteries to soak up the excess and if there's been some improvements under some networks to carry the capacity. So it's a bit of a complicated issue and it is frustrating if you're really keen to install more solar. Um, and it also depends on how much you use versus, because if you're using all of that 10 kilowatts, then it's really not an issue. But if you're not, then it could be, and the network doesn't necessarily know if you're going to regularly use it or not. So there's a lot of issues in it, but hang in there. Install as big as what you can get, what you can, and I think there's a lot of change in this area still for the next 10 years.
We've got a bit of a comment from Bryn. Says that they think that it's worthwhile asking what the refrigerant is that is used. Some of the gases used have extremely high greenhouse gas factors. Losing a kilo of gas is like several tons of CO2 going into the atmosphere. CO2 is definitely the least impactful refrigerant gas that they're aware of.
Yeah, no, this is
But
spot on. And
yeah,
I normally mention that in the presentation, but I think I was racing through it a bit. The refrigerant gas really, the biggest impact is at the end of life of the appliance or if there's a fault that leaks it out. So if you're particularly concerned, I mean, there's standards for what can be used and what can't be. There's limitations, but some of the gases have a um, higher greenhouse impact than others. So
yeah,
definitely, if you're concerned about that, I would look at I'm just trying to remember I think it's called the global warming potential of the refrigerant. Um, yeah, there is a list. If you're interested, let me just copy this link and put it in the chat. Here is a list of refrigerants and and it talks about like the global warming potential of them and everything. If you're interested in that. Um, and yeah, it seems ironic, but carbon dioxide, the thing that we use to measure greenhouse emissions, is actually the least global warming potential of all the refrigerants, because all the other refrigerants are worse. So the gold standard for refrigerants is to use carbon dioxide, and there's a few other ones that are safe for the environment, and they include propane and ammonia as well. Again, things that we think of as not as necessarily safe gases, but they've got lower global warming potential than some of the others. So it's a complicated area. That link there has some good information about it.
okay. Um, Back to the previous question about the solar system.
Yeah.
I've just got a follow up saying, won't I need this excess solar generation to power my electric car into the future?
So what if you need it or will you need it?
Yeah, they saying, yeah, won't I
Yeah,
need,
no,
yeah,
that's true. That's true. And that's where one place I'd like to see the networks go is to allow bigger systems to be installed, but have a limit on what can be exported. And some of
yeah,
them are doing that. And I'm a bit less up to date with what the New South Wales networks are doing at the moment, because I haven't been doing much stuff with them for the last year or two. But that is the way forward, because the issue is not about people using electricity. The issue is about the exports. So yeah, if you can arrange to get your system export limited at whatever limit it needs to be, and then be allowed to install higher capacity for future EV, that's that's worth it. But then the other thing is you can always add more solar panels to your system in the future when you get an EV. That's the other option as well. And things might have moved along a bit in a couple of years.
yeah. I've just seen Doug's comment in the chat. He's saying
Okay.
that he's got a 9 kilowatt solar system, but a 5 kilowatt export limit so
Yeah.
that the grid stays happy, but he has heaps of solar and they charge their EV. So,
Yeah, no, that's a good point. Yeah. And one of the other things to think about with EVs is that we often think about the fast charging, which it takes a lot, but a lot of EV charging is at home is slow charging, and then you can use it over the longer period of time, and that way you can actually use more of the energy from the battery or from your solar. You don't need it all at once. Yeah.
yeah. Another question. Where should people with older homes start? Insulation, solar, or appliances?
I would
Or
always
draft proofing?
Yeah, I would start with insulation and draft
Yeah.
proofing, like ceiling insulation and draft proofing. Wall and floor insulation can be really expensive and not that worth it. Depends on the house a bit, but I would start with ceiling and draft proofing and then live in it for a while and see what your energy usage looks like when you've done that. Then I would think about efficient appliances, and I would do solar after that because in the end you want to actually scale your solar to your usage. That gives you the most bang for buck from your solar, especially now that exports are you don't get much for exports and that can cause problems. If you can be a bit patient and do your insulation draft proofing, get your efficient heater and hot water system maybe, but even if it's before you get, say, your hot water system, you can sort of estimate. It's a bit easier with the hot water system to estimate, oh, this is how much it would need to use, even if you've got, say, an old gas hot water system. So I would do it that way. Get a good sense of what your usage is going to be with an insulated home, and then use that to do your calculations. And the links that Doug put in the chat before to work out your battery, those links also have good solar calculators where you can put in your usage and your postcode, and it'll tell you, hey, this is the ideal solar system size for you to get the most value from it. So yeah.
We might have this as the last question. It says, how long before solid state solar batteries will be available here in Australia?
That's a great question. I have no idea because I'm totally not an expert in battery technology. Like, it's one thing to look at how batteries interact with solar systems and electrics and electric supply. It's another to go right into the nuances of how they're made. So I just don't know. Sorry. I would Google, or maybe Doug knows something about that. I'm not sure. Looking expectantly at the webinar chat, but yeah, I don't know. Sorry. That's a good question though, and there's a whole world of interest in different battery technologies and how they work and how the prices are coming down, all that sort of stuff. So, yeah, totally.
Yeah. And I think with that battery rebate coming in November, I think there's just going to be more and more questions about batteries.
Yeah, and you know what? This is a great question. If you come to the webinar, what, next week or whenever it is, that Andrew, I think, is doing, he knows heaps about batteries. It's a great question for him. Yeah.
I might write that one down for him.
Yeah, I would totally do that.
All right. Perfect. Well, thank you everybody for coming, and thank you, Dean, for your expertise, and thank you, Doug, for running the group chat with all the links. Um, there will be, yeah, a copy of this will be uploaded to the council website in the coming weeks. So if you want to go back over anything, it'll be uploaded. And we can always send out that link to everyone as well if you want to refresh on anything we went through tonight. But yeah, thank you all for coming.
Yeah, thank you. Thanks for having me.
Thanks. All right. I'll see you guys.